great to be back and wonderful to see so many of you back to see our webinars, but also so many new people, familiar faces and new ones. So warmly welcome to another webinar in our Beyond PFAS series. So in this series, we usually take on alternatives to PFAS uses that are considered complex or difficult uses. This time, however, we will look at a use that is often referred to as an easy case, the PFAS-coated non-stick frying pans. There is nothing new with cooking, with frying food in a pan. Traditional pans have been used for centuries to build up our famous culinary cultures. And in the 50s, the chemical industry found yet another way to use PFAS and started to produce non-stick frying pans with PFAS coating. And now, due to the global PFAS pollution crisis, the EU is working on a restriction to ban a wide range of uses, and the frying pan use is considered to be an easy case to phase out, as there are alternatives available. I mean, anybody who has been looking to buy a frying pan knows this. But to our surprise, the non-stick frying pan industry has put immense pressure to influence policymakers in, for instance, France, a country aiming to move ahead of the universal EU restriction. And because we've seen this rather strange debate happening, we decided to clarify once and for all what the alternatives look like. So this is what we will talk about today. The recordings and slides from today's webinar will be made available. I am Teresa Schell, Head of Policy at Chemsec. And with me today, I have three company representatives to shed light on both how the alternatives work and the retailer perspective. It is Dr. Chris Phillips from the Cookware company, Dr. Ralph Wilken from Fraunhofer Institute, Louisa Wright Sørensen from Coop Denmark. And for the panel discussion later on, Dr. Jonathan Kleimark from Chemsec will join as well. So after the presentations, there will be an opportunity to ask questions to the panel. So please note down any questions you have in the Q&A box below in Zoom, and we will do our very best to answer them. And with this, I would like to hand over to our first speaker, which is Dr. Chris Phillips, Senior Consultant for Engineering and R&D at the Cookware company. He has 36 years of experience in materials and coatings. He currently provides technical training for colleagues in the Cookware company group, with particular focus on kitchenware products. Sorry, there's someone speaking. So I'll just take that. So he currently provides technical training for colleagues in the Cookware company group, with particular focus on kitchenware products that are free from PFAS, as well as from other toxic materials such as endocrine disrupting chemicals. Chris, go ahead, the floor is yours.
Thank you very much for that kind introduction. I think everybody's got the title of the talk today. Could we move to the next slide? My aim today is to simply share with you that there's a viable alternative to PTFE non-stick, and that's ceramic non-stick. I want to show you that there's nothing difficult about the application, and you won't need to invest in expensive new equipment. My disclaimers are that I have no commercial recommendations to make regarding coatings. Sol gel's available from most of the non-stick coating suppliers. I'm just here to share our experience about how we implemented this. Next slide, please. Before we begin, I'd like to show you some trends. Before 2007, the cookware non-stick market was mostly dominated by PTFE. Since we launched Green Pan in 2007, the market has gradually shifted away from PTFE towards ceramic. One market survey shows that ceramic non-stick occupies something like 40% of total non-stick sales today, and consumer buying intentions are ahead of that, meaning that there's still driving force in the market. And this is all very well aligned with regulatory trends worldwide, which I'm sure you're all aware of. So next slide, please. This is just another survey, Homeworld magazine, and that shows basically the same trends, but by time. Next slide. Now let's look at some general differences. PTFE non-stick, it's based on PTFE. It's a polymer of tetrafluoroethylene, TFE. Sol gel, the structure's based on silicon, oxygen, silicon, oxygen. They both have a long history, and with PTFE, it was discovered in 1938 and first found its way onto cookware in 1958. Sol gel originates back in the mid-1800s, and it's had various industrial uses since the 1980s. PTFE, well, it's a polymeric PFAS, so those coatings aren't PFAS-free, whereas we can say that our sol gel and all the sol gel that we have come across are PFAS-free. Next slide, please. All coating materials are made of some ingredients. In PTFE non-stick, it's the PTFE dispersion that provides the non-stick component. And if you average over 2 or 3 layers of PTFE, then it contains about up to 35% of PTFE. And that's was in the form of a dispersion rather than solid PTFE. Next part. Sol gel also has ingredients. In this case, the binder is sol gel precursors, and they join up during maturation. I'll show you more of that later. The additive in orange, it's a catalyst. It's a naturally occurring acid that speeds up the sol gel process. There tends to be not a lot of additives in sol gel because they could take part in the sol gel process, causing unpredictable products to be formed. So generally, less additives, maybe just a drop of silicon oil to help with the leveling of the coating. Next slide. Looking at the difference in the properties, they're both considered food contact safe. There's some plus or minus differences on both sides. What most people are interested in is the non-stick longevity. Unfortunately, we have 2 very different materials, PTFE, which is a polymer, and sol gel, which has ceramic-like properties, and it's very difficult to compare 2 different materials. It's like using the same test methods to compare wood and concrete, and you wouldn't do that. But fortunately, nevertheless, we found that there's one good test which is used for LGA accreditation. It's called the LGA shaking table test. I think everybody in the industry is very well familiar with that. And if you compare PTFE and Thermalon and ceramic non-stick, they both come out in the range good to satisfactory. LGA good means high quality premium cookware in the market, and it's very durable and robust. So essentially both are durable non-stick technologies. Next slide, please. Now let's look at the application. PTFE is quite simple: primer, mid coat, top coat. You just have to roll them before you apply them. Sol gel, they come as 3 separate solutions that you have to combine. You need to follow the application guidelines of the suppliers. It's not complicated. It's just like following a recipe. Once you've combined these, they need to be agitated for a certain time. So the only thing that you need to invest in would be a set of rollers or a rotating impeller in a vessel. In other words, an investment which is less than peanuts. Next slide. With both technologies, the substrate needs to be pre-treated, which means degreasing before sandblasting. This is the roughening part is slightly more critical for ceramic non-stick because unlike PTFE, there's no adhesive primer. With PTFE, that primer acts like glue onto the metal substrate, whereas ceramic, that relies purely on the roughness profile to form an anchor pattern, and then it's a lock and key mechanism of adhesion. So you just have to observe those parameters slightly more carefully, but all factories have a roughness meter and are capable to do this. Next slide. With both types, then the substrate needs to be preheated before the pans come in front of the spray guns. The temperatures are just slightly different for PTFE and sol gel. That's simply a matter of setting different temperatures on your preheat oven. So no new investment is needed. Next slide. Spray equipment, exactly the same. So you can use your existing spray guns, your existing spray booths. Ceramic non-stick is slightly simpler here because you're applying the first layer and the second layer wet on wet. It's just film height building within the same spray booth. Whereas PTFE, you'll need a separate booth for the primer, then a drying oven, and then depending if you have a mid and a top coat, you'll have another 2 spray booths as well. But you can use all of your existing equipment if you have a spray line that can apply PTFE. Next slide. The curing process, the ovens are exactly the same. Set ceramic non-stick cures at a lower temperature, and generally it spends a shorter time in the oven. So that potentially will transfer into higher productivity. Your pans go through faster with lower energy used during the curing process. You can use your existing ovens, so no new investment needed. Next slide. So drawing all of this together for you, hopefully you can see that there are no significant barriers. Ceramic non-stick for cookware, ovenware, small domestic appliances, it already exists in the market. Anybody who can apply PTFE has the right skills and equipment to apply ceramic. You don't need any new investment. And for the coating companies, there are no socio-economic consequences because most of them are already offering both solutions to their customers already. Cost is definitely not a barrier. We've been producing ceramic non-stick kitchenware for 17 years. We sell to the mass market retailers at very affordable prices, and I'd just like to underline the word affordable here. So next slide. Here are some common questions, and just in view of the time constraints, we can cover those in the Q&A, or I can come back to them. But I'd just like to go on to the final slide, if we may. And that's to really look at the sustainability and the safety of sol gel. It's really been applied on cookware for 17 years, PTFE since 1958. So let's actually look at the facts here. We have the coating manufacturer and the application all under one umbrella. They're sister companies for making the coating and applying it. So we can confirm that VOC emissions during manufacture and application of the coatings are low. They don't place a big burden on your wastewater treatment or VOC capture. Additionally, there are no persistent organic pollutants in the manufacturer's sol gel. We've had several green pan ranges assessed by Cradle to Cradle. The common feature between those ranges and all of our green pan is it's the same Thermalon sol gel. So that came out with a bronze certificate, which is good. And there's no reason why other sol gel manufacturers can't do this. And then finally, the last important point is that our Thermalon sol gel that received NSF certification. So that means not only can we apply it on domestic cookware, kitchenware, it can also be applied on industrial and commercial food preparation equipment, which hopefully demonstrates to everybody that this is a really robust solution. So I'd like to conclude on that. So thank you very much, and I hope that you've all got the message that there's really nothing that should be holding you back. Thank you.
Thank you so much, Chris, for that presentation. And I see that we already have some questions in the Q&A box, and please, to the audience, keep on putting them there and we'll have a look at them and try to answer as many as possible. So for the next speaker, we have Dr. Ralph Wilken, who has a PhD in physical chemistry and works since many years for Fraunhofer Institute for Manufacturing and Applied Materials Research. A large part of his work has been dedicated to studying and developing coatings, and he is currently head of division for surface technology. The floor is yours, Ralph.
Yeah, thanks a lot for the kind introduction. And thanks a lot to giving me the opportunity to talk a little bit about our PFAS-free anti-stick coating, which we call Plaslon. It's an excellent alternative to PTFE-based coatings. Next slide, please. So just some information where I come from. I come from the Fraunhofer Institute for Manufacturing Technologies and Advanced Materials. It's one of the 7 institutes of the Fraunhofer Gesellschaft. We have about 700 employees and have 7 million euros budget, and we have also 7 locations, and the headquarter of the Fraunhofer Institute, it's Bremen, where I'm also located. Next slide, please. So our institute is dealing with, or is divided into 4 divisions. One division is dealing with surface technologies, where I'm the head of. And we deal with surface and nanostructure analysis, also with pre-treatment technologies, wet chemical, as well as dry chemicals treatments. We also deal with the development and deposition of functional coatings like plasma coatings, plasma-based coatings, but also painting technologies is used, and also some sophisticated electro-based technologies are in-house. And last but not least, we also deal with the process integration and also the quality control with, for example, inline surface analytical tools. Next slide, please. And now I'd like to talk a little bit about the Plaslon coating. It's a hard anti-stick coating. It's innovative, sustainable, PFAS-free, and economical. So that's what I will present right now. So the Plaslon coating is a PFAS and also fluorine-free non-stick coating, specifically designed for the food processing sector as well as household appliances. It combines excellent non-stick properties with very high hardness, mechanical resistance, and temperature resistance. The Plaslon coating is a non-porous and food-safe coating. It also exhibits oleophilic properties with edible oils and fats. Next slide, please. So if we just talk about the expectations of the consumers. So they expect an efficient, long-lasting non-stick coating for household appliances, for example, for frying pans, roasting pans, oven dishes, knives, and so on. And the producers of these products, they're expecting a safe and sustainable non-stick coating at market prices. So it should be quite cheap. So the required basic characteristics are, should be food safe, PFAS-free, free of fluorine compounds, should be non-porous and neutral in taste, and should also have high mechanical resistance. Next slide, please. Now we come to the Plaslon non-stick coating. It's a highly cross-linked PECVD coating. It's deposited at room temperature directly from the gas phase. It's suitable for stainless steel, enamel, porcelain, for example, also stoneware, ceramics, and also glass. And it's based on silicon organics, as let's say the Sol-Gel systems. But the main difference is it's based on a PECVD coating, which comes from the gas phase, not from the liquid phase. This technology combines, let's say, the ceramic and organic properties. It has a high degree of cross-linking, which determines the chemical and mechanical properties. And that's more or less also, let's say, the unicorn powder. The coating has, let's say, two kinds of networks. One is based of silicon and oxygen, so that's quite typical. That's also something which is used by the Sol-Gel technologies. But we also have a second network. It's based on silicon carbon, and this really makes it new. This makes it also very hard. It's as hard as animals, so the most hardness is about 5.5. It's really mechanically resistant, non-porous, neutral in taste, provides good, long-lasting, non-stick, and easy-to-clean properties. It's also oleophilic, which makes it also better for cooking because the oil is spreading on the bottom of a frying pan, for example, and this gives better temperature distribution on the bottom of the frying pan. The temperature ranges up to 250 degrees Celsius, and the coating depicts also laser structures and labelings perfectly. Next slide, please. Now we come to the coating costs. The Plaslon coating is particularly suitable for serial production. Also medium and large volume machinery can be implemented, as well as clock continuous machinery. This is especially interesting if it comes to high volume production, so that we end up with a very high degree of automation. Concerning the coating, we apply only very little amount of coating thickness, so it's about 150 to 250 nanometers, and therefore we only need minimal quantities of chemicals. The coating itself is also quite fast, takes only few minutes. In addition, the process is cold. We do not need any curing step, no oven or so. We only need some energy for pumps and the electrical discharge. For example, if you calculate the power consumption of one frying pan, it's less than half a kilowatt hour. Therefore, the coating costs, the running costs are extremely low, especially in mass production. Next slide, please. Now we come to the sustainability. As I mentioned already, the coating process only requires small amount of chemicals and also small amount of energy. The machinery itself, it's also very robust and long-lasting. We need initial chemical compounds. The used initial chemical compounds are PFAS-free, and they are also fluorine-free. Also, the coating itself is fluorine-free. And if it comes to recycling, for example, a stainless steel frying pan, you do not need to decorate it first, so there's no decoating. There's no decoating necessary. Sorry. Next slide, please. I'll come to the conclusion. So the Plaslon non-stick coating meets the customer requirements. It's particularly regarding the mechanical resistance. The coating process is sustainable and easy to reproduce, and it can be applied economically to a wide variety of substrates. Next slide, please. So if you ask how to get it, we have some different kinds of distribution models. You can have a non-exclusive license combination with a plasma machinery, or we also developed a shop-in-shop solution. but you can also use, let's say, some job coaters to get this coating. So if you have if you're interested, please ask. Thanks a lot for your attention.
Thank you so much. And the questions are just flooding in. And you did actually answer a few in your presentations. That's also really good. But we have a lot of questions for the remaining Q&A. But before that, I want to introduce our last speaker, giving the retail perspective, and that's Louisa Reit Sørensen. She's responsible for Coop Denmark's chemical strategy and efforts. For the last 10 years, she's been involved in Coop's proactive work with PFAS and PFAS substitution. And for many years, Coop has been working to develop standards to prevent chemicals of concern. The floor is yours, Louisa. I think that you are muted.
Yeah, so I started sharing but forgot to unmute. But I think there it is, and presentation mode as well.
Perfect.
Thank you very much for the kind introduction, and thank you very much for drawing attention to this very important agenda. As Teresa just said, I've been working at Coop Denmark with PFAS and PFAS substitution for the last 10 years. And today I will give you a very brief introduction to Coop Denmark, as well as a brief introduction to how we have been working with PFAS and PFAS substitution for the last 10 years. After that, I will also share some insights on our work with PFAS and frying pans and introduce you to the PFAS-free label we use on frying pans and baking items in our stores. Coop Denmark is one of the largest retailers of fast-moving consumer goods in Denmark. We have a market share of 33% and more than 1,000 stores all over Denmark. Coop Denmark is a cooperative, which means that we have no shareholders, but instead we are owned by 2 million members, 2 million Danes, which is more than 1/3 of the Danish population. And because of our ownership structure, we have a long and proud tradition for working with responsibility and sustainability. And we like to say that responsible thinking is part of our DNA. When it comes to chemicals of concern, we collaborate with scientists, experts, and NGOs on chemical issues. And we have been developing standards to prevent chemicals of concern, such as PFAS, BPA, and phthalates. And we have also worked systematically to phase out PFAS from our assortment since 2014. And of course, it also requires a lot of quality control when we are ahead of legislation. So just to specify, our PFAS ban is described in our trade contracts. We have an ongoing dialogue with our suppliers, and we're helping them to understand and comply with our special requirements. And then we also have a random sample test program where we make sure that risk products are tested to ensure that they do not contain PFAS. Our work with PFAS and our PFAS ban started back in 2014, where leading experts started to link the exposure of PFAS to serious health effects. And also the Danish authorities emphasized the need for increased awareness of these substances. So back then, we banned PFAS in food contact materials of paper and board, and we started to phase it out of our packaging. Actually, the problem wasn't as widespread and difficult to solve as we feared and expected, but we experienced one big challenge with microwave popcorn because it was simply not possible to find a microwave bag without PFAS. So we removed popcorn from our shelves back in 2015. And It resulted in massive media coverage, and we also experienced increased consumer loyalty back then. And over the years, we have banned PFAS in many other products, most of the products that we sell. So we have a ban in textile, outdoor, apparel, furniture, shoes, cosmetics, personal care products, and dental floss. And for now, we are working with our suppliers to find alternatives to PFAS-free frying pans and kitchen appliances. We already have a broad assortment of PFAS-free frying pans and baking items. When it comes to our own brands, Coop's house brands, we have a ban against PFAS in frying pans, baking items, and kitchen appliances. And we are also working together with our suppliers to find alternatives to PFAS in frying pans, and we are aiming to have an even broader assortment of PFAS-free kitchen appliances, and we are aiming to phase out PFAS from our entire assortment. At least in Denmark, the consumers are very aware of PFAS. 69% of the Danish consumers know of PFAS and wish to avoid it. And actually, frying pans is the product the consumers primarily link to PFAS. And also 4 out of 5 are not aware of which products to buy that do not contain PFAS. So we introduced a PFAS-free label, and we launched that label to guide the consumers to the PFAS-free frying pans and bakeware that we already have in our stores. And the label gives our customers the opportunity to buy products, in this case, frying pans and bakeware that are free from PFAS. And of course, again, we only use it in our own brands, the Coop house brands. So this is the status from now, but we will continue to fight for a PFAS-free range in all our stores. In conclusion, I would like to highlight that we have over the years learned that it is possible to produce packaging, but also other goods without PFAS. It is also our experience that when you ban PFAS or other harmful chemicals, positive innovation will happen. Also, the Danish consumers wish to avoid PFAS, but they lack information to select PFAS-free products. We all know that legislation can be several of years in the making, but it also leaves the industry and the companies with a responsibility and an opportunity to act and innovate. We believe that it's important to move away from PFAS in frying pans because it's simply not necessary, and we know that there are very good PFAS-free alternatives, as we also just heard. And at Coop, we believe that the way forward is to approach business in a broader perspective and address quality and properties as well as consumer safety in the business solutions. So that was it.
Great. Thank you so much, Louisa, for giving that perspective. I think it really contributes to the debate to see how it actually works in reality. So with that, I would like to start the Q&A session. So I invite the other speakers to be part. We have gotten already quite a lot of questions that will be difficult for us to answer, but we'll do our very best. Picked out a few. And one that I would like to start with is that, and I just take it from my mind from reading several of them, but that it's true that we see a large increase in the use of these alternatives the last decade, but there is still quite some use of the PFAS versions. And could you give some explanation to why that would be? If any of you have something to add to that. That would be interesting to hear.
I could maybe add that consumers are quite slow to change their cooking habits. If their parents cooked with a PTFE coated pan, it's likely that they may be as well. People don't like to throw things out that may be still working, but we know that consumers' future buying intentions have switched something like 46%, if I remember correctly, or 48% for ceramic, 36% for PTFE. So it's gradually changing over time. We've seen this over the last 17 years. The public awareness, particularly with documentaries and newspaper articles, is becoming more and more. So I think the young consumers who want transparency and to have healthier products and care for the environment, they're going to be the ones going forward who will drive the demand. And then you've got the regulators in Europe. If we think what happens does happen, that PTFE on domestic cookware will be restricted with perhaps an 18 months grace period. So by then, I think you may say that the trend was slow, but once something starts happening, it happens quicker than you could ever imagine it could do.
Great. Thank you. Anyone want to add something?
I have heard from the industry that they believe that the PTFE kitchen appliances are of a better quality. That is not my personal experience. And as we know, and as I just said, the Danish consumers do not necessarily know which product that are free from PFAS. So yeah, I think it's just a matter of time.
Yeah, thank you for giving that perspective as well. Now I have a rather technical question, which I am very curious of myself. The question is, are there any concerns about sol gel technology regarding the siloxanes emissions, or is that a totally different material in chemistry?
Okay, I can probably answer that one. So what the questioner is probably thinking of is a precursor that's a very long way back in the manufacturing chain. So when you have the coating, you mix the solutions A, B, and C. They react to form a new material. They form oligosilanes. And then when you spray the coating onto the substrate and you cure it, you get a highly cross-linked, dense ceramic-like film on the surface. So the composition is nothing like those precursor materials at the very beginning. It's like saying water is made from the reaction of hydrogen and oxygen, but quite honestly, water doesn't look like those two gases, and sodium chloride, table salt, doesn't look like a metal that spontaneously combusts with water, or chlorine, which is a green choking gas. So I think there's a little bit of confusion in the questioner's mind. And if they want to reach out on that subject, I'll be happy to talk to them.
That's great. Thank you very much for clearing that out. And here I do think it might be the last question we have time for. We have a question for Louisa. It says, Louisa says banning microwave popcorn from Coop's shelves has increased their customers' loyalty. Could she explain how this has been verified and whether they expect phasing out PFAS pans will also have an impact on this sense? Is this something that they publicized somehow?
For the last thing, I don't know, but we experienced this increased consumer loyalty in many ways when we removed the popcorn from the shelves. First of all, I think we had a lot of positive media attention, and then we like on social media we experienced many hundreds and hundreds of positive comments, and of course there might have been a few not positive comments as well, but it was like overall very positive feedback we got from our customers. And then I also remember that from a human resource perspective, we also realized that more people wanted to actually work for a sustainable company like Coop. So we experienced it many different ways. Yeah.
Thank you. That's really interesting to hear. We have received, like I said, a lot of questions. We'll have a look at them and see if we can forward them to the different speakers. And as they've all said, you are able to contact them after the webinar or us if you have some particular questions or would like to follow up with something. So with that, I'd like to conclude. And I mean, it's different this time because we're talking about a use where we do have alternatives to the PFAS uses. So I just want to start out with emphasizing that there is a need to address all uses of PFAS in order to turn off the tap to stop this accelerating pollution. And this includes uses like frying pans. For uses that clearly have alternatives like this one. I mean, for the pans, we also have equivalent functionalities, the same pricing. It's really a no-brainer. So let's continue by discussing the complex cases, the green transition uses, and not the frying pans. It's time to ban this particular use. I mean, PFAS is already in our blood. It shouldn't be in our frying pans, not anymore. So with that, I want to thank all the speakers from today and encourage you to keep an eye out for our upcoming webinars in this series. We have a packed schedule for the autumn, and I'm sure it will interest you. I hope to see you all then. Thank you very much for today. Bye.
Thank you. See you. Bye.